logarithms by using something called a log loop. And a log loop is really just another way to write an exponent. This number down here is called the base of the exponent. Your calculator, you may have noticed, has a log button, right? You've seen the log button. That log button on your calculator assumes down here is base 10. Your calculator is base 10. It's 10 to some power. And what this log loop means is that 6 raised to the second power is equal to 36. That's called a log loop, right? So if I asked you to rewrite this, this is what you would write. You would write 6 raised to the second power equals 36. This one, log base of 2 raised to the 5th power is 32. 2 to the 5th is 32, right? Right? Over here, this one, even though it's fractions and negatives, 4 raised to the negative 2 power. Remember, negative, you put it over 1, you move it. So that's true, right? It's equal to 1 over 16. So it doesn't just have to be all positives and all whole numbers. You can have fractions and negatives, but it still works out. 4 to the negative second, 1 over 16. Agree? So the first part of what you're going to do today is go from one to the other. They're going to give you this logarithmic form and ask you to just write it in exponent form. So that's what these are. And all you have to do is use that log loop. Start here with the base, raised to this power equals this answer. And that's literally all you have to write. 5 raised to the second power equals this answer, 25. And that's your answer. That's all you have to do. That's easy enough, isn't it? How about this one? 10 raised to the negative 3 equals 1 over 1,000. Yes?
Would you have to square root the 5?
Not in this case, because all they're asking you to do, they're not asking you to do anything except write it in exponent form. So you would just leave it like this. You wrote it in exponent form, you're done. That's all they want, right? And same thing with this one. 10 raised to the negative equals 1 over 1,000. How would I write this one? Great. How would I write 2 raised to what? Equals 64. So that much is easy. And this is just your answer. By the way, can I point out there isn't really any work to show? You just write the answer and you're done, right? If you're not sure if you wrote it right, look at it and see. Is 2 to the 6th power 64? Is that equal? Yeah, so you know you did it right. So any questions on this part so far? The next thing they ask you to do is go the other way. They give you this part and they ask you to write it in logarithmic form. So how are we going to write this? Log 7 goes down here.
49.
49. The answer goes next, and then the exponent is what it's equal to. So it's a 2 here, right? And if you want to know if you did it right, do the log loop. This raised to this power equals that answer. That's right, isn't it? This, the base. This thing is your exponent, and this one is what the answer is when you're writing it out, right? So how would I write this one? Log of, what goes down here? 2. Here goes the answer. What's the answer? 8 equals, the exponent is 3. And double check with the loop. Is it this raised to this power equals that? 2 raised to the 3rd is 8. How about the last one here? It's log. What do I put on the bottom, the base? This. Here goes the answer. What is that, Miller? Right? You're right. It's 1 over 125. equals, what's the exponent? -3. And then do a loop and just double check it and see, is it this thing raised to this power equals that answer? Yes. So that's not really that difficult either, is it? It might take you a little bit more thinking, but it's not really that difficult. You're just not used to it. Any questions on this part? Again, there's not much work to show for this either, right? So you'll just probably have answers. Questions on either of those so far? The last thing that you're going to have to do is simplify. And by the way, what did we just get done doing? A bunch of sections on? On what? On what? On what? Right, exponents. So guess what you're going to use when you simplify these? Exponents, right. So the first thing that you have to do when they ask you to simplify any of these is set it equal to x, always. Set it equal to x so that you can do a log loop. Once you set it equal to x, do the log loop. This thing raised to that power is this. So 5 to the x is 25. And now you're just going to solve that. It should look very much like what we've been solving in the last few sections, right? What do you have to get when you solve these? Did you say like bases? Did you say like bases?
Yeah.
Like bases?
Yeah.
Like bases, right? What's my like base going to be? 5. That's already a 5. How do I write 25? Once you have the like bases, what did we do with those?
Got rid of them.
We threw them out, right, very good. And we set the exponents equal. So what is x? And you probably could have figured that out with the like bases, but then you wouldn't get credit for it, right? Does that make sense? So what's the first thing you're going to do here? Set it equal to x. Set it equal to x, and then do your log loop. Starting down here, raised to that power equals that answer. 2 raised to the x power equals that answer. Oops, not an x, a 2, right? 2 raised to this is this thing with a 2 under there. What did you have to do next? Like bases. What's my like base going to be? 2. So I have to write this. How do I write 8 as a power of 2? 2 to the third. How do I write the root of x? Or the root of 2, I'm sorry. How do I write root 2? 2 to the? Because square root is 1/2 power, right? Like, what do you do to the exponents? You add them. So I have a 3 plus a half. You can either write it as 3 1/2, or if you want to write it as 3 to the 7/2, I don't care, either way. Once you have the like bases, what do you do to them? Throw them out. You throw these out, and you set the exponents equal. So what is x? 3 1/2. Or 7/2, either way, I don't care. Does that make sense? Does that make sense? Does that make sense? Are there any questions? Questions? Anyone have a question? What's our assignment? That's good, Dogford. Our assignment. I think I'm on.